someone is coming to learn the Java, no need to know about C or C++. Okay, though they don't know anything about C or C++, they can easily learn Java language. So that's why we'll call it as a nursery language. Okay, nursery language. Okay, the third one is what I told you guys. I had told you one important point for simple. What is that? Anyone?
Without any coding knowledge.
Yeah,
Without any pointer.
Without any coding knowledge, we can able to proceed. So here in C and C++, we have a lot of complex features, complex and confusing features.
Pointer and some inheritance.
Yeah, confusing, most complex and confusing features we have in the C and C++. So that is pointers. Pointers concept is very complex in C and C++, and we have
Inheritance.
multi-inheritance. This is also very complex to use it. So whatever the complex features present in C, C++, those are removed, and whatever the easy features that are present in C, C++ were taken and developed here in the Java language. That's why we are calling Java is a simple. Java is simple. It is one of the features. Okay. Complex and confusing features. Complex and confusing features were removed in Java language, like pointers, multiple inheritance. Okay. So lot of things are there. So these are the two examples that I can give. So me too don't know about C++, but I learned Java. So I know about C, but I don't know about C++ anything. Still, I can able to learn Java programming. Okay. So no need to have any Java, no need to have any programming language to learn Java. So it's easily understandable and easily we can write the code easily in Java program. Just we need to understand the concepts that we need that I'll be going I'll be telling in the future. Okay, this is simple. First one is simple. Okay, you guys understand simple? Why simple?
Yes.
The next one is, what is the second one? Object oriented, right?
Platform independent.
Yeah, platform.
Okay, object.
Anything is fine. Platform independent. Platform independent. What do you mean by platform here? So platform is OS. Windows, Mac, Linux are the three operating systems that we'll call it as a platform. So if you write any Java program, this is a Java program that we have written. Okay, this program can be run in Windows. This program can be run in Linux. This program can be run in Mac. We no need to change anything in the program, though we are running in different operating systems. Okay, how it is running in different operating systems. But if we take C or C++, we can't run it in different operating systems. So in C, definitely, whatever the program that we write in C, if you want to run it in Windows, we can run it in Windows. If you write a program for Windows, we can write it. If you want to run it in Linux, then we need to change our program. So changes are required to run it in the Linux. Changes are required to run it in the Mac. So, but in Java, it's not required. If you write a program in Java, then the same program will be running on the three platforms: Windows, Linux, and Mac. That's why we'll call Java is a platform independent. Okay, how it is running? How it is running in three operating systems. Okay, so initially, whatever the code, suppose
Some
if you
no. Sorry for the disturbance. Some noise is coming. I don't know.
noise is coming.
Yeah. Some sound,
Some telephone sound.
telephone sound or something. I don't know.
Okay, wait 1 second. Still, you can hear the sound of the sound.
No.
No. It's fine.
Sorry. So that's why we'll call it as a platform independent, because Java program, whatever the Java program that we write in one language will be, whatever the Java program that we write, the same program can be run in Mac, Windows or Linux, any operating system. How it is happening? So suppose I have written a program, class, suppose I have written a program class student. Okay, static void main string args. So this is the main method. Scope is hello world. I written a program. Okay, this program I'll be saving as .java. Okay, suppose I'm saving student.java. Whatever the program that you write should be saved in student.java. Suppose this is the class name, then we should save this program as student.java with the class name. Okay, that I'll tell you later. Just remember now. So this is .java file. This will call it as a source file. This will call it as a source file. So whatever the program that we have written, that will be saved in student.java. This is the source file. Okay. So .java file is a source file. Listen properly. Source file. Okay. This will be converted to dot class file. Dot class file. Class student dot class. Okay, which is in bytecode language. Don't worry about the bytecode language. Bytes means 0, 1, 1, 0. It will be 0, 1 language, bytecode language. Okay, 1 and zeros. So whatever the program that we have written, this source file will be converted to bytecode language when we compile. When we compile the program. So whenever we write a program, we need to compile it because it will check whether we have any syntax errors. Okay, if we have any syntax errors, it will check and do the result. If we don't have any errors, then it will do the success. Okay, that this Java file will be converted to .class file. So suppose we have saved your .java program in Raja folder. Same .class file will be saved there. Once we compile .java, wherever we have saved the .java file, there itself it will be created one more class file. Okay, so student.java is a program that is source file, and student.class will be saved once we compile this program. Compile means we are checking if we have any syntax errors. Syntax errors means suppose system.out.println hello world. Okay, this is the one of the command that we are writing to print the message hello world. Okay, but after every statement we need to give the semicolon. If you don't give the semicolon, while when we compile it, it will tell us that we didn't give the semicolon at particular line of code. Okay, it will give an error. The compiler will throw an error saying that compilation error at the line of code 4 where it has missed the semicolon. Okay, it will give an error saying that semicolon has been missed at the number line. Whatever the line it is present, it will be thrown an compilation error message. Okay, just remember this. Just remember what is source file. What happens when once we compile it? Okay, once we compile it, what happens? It will be created dot class file. That dot class file will be in bytecode language. Okay, bytecode language means it is because whatever the source file that we have written is in totally in English, right? Is totally in English, right? Are you understanding? You need to respond.
Yes.
Sunita garu, Ajay, Nikunj.
Little bit confusing.
Okay, so let us assume that we have written a program.
Okay.
So class student static void main string args system.out.println hello. How it is in? It is in English only, right? Just it is in English language, right? Class student static void main. This is English only, normal English only, right?
Yes.
Yes.
Yes. So whatever the language that we use, English, whatever the language that we have used here, suppose English, this English language can't understand by the system. Operating system won't understand this language. Okay, OS operating system won't understand this language. So what operating system will understand is it should be in bytecode. It will be in zeros and ones. Okay, that should be in zeros and ones. Whatever the source file, this is the source file. We are converting this source file, whatever it is in English language, we are converting into bytecode. System understanding language. Okay, system can understand only bytecode language. That will be in zeros and ones. Okay, once we compile this program, this will be converted into bytecode language. So it will be in zeros and ones, which every operating system will understand this language. Okay, because of this conversion from source file to bytecode, okay, every operating system will understand this bytecode language. That's why whatever the program that we write in Java will be running on every operating system. Okay, once we compile, it will be converted into bytecode language. Then then it will be converted to machine code language, machine code or native code language, then executed. Okay, JVM will take care of this. Converting from bytecode to machine code language will be taken care by JVM. Okay, under JVM will be having interpreter. So initially you feel like because you are listening all the words like class, static, void, main, system.out.println. These are new for you guys. So that's why JVM, .java, .class, compile, JVM. So everything is new. Everything is new for you guys. So that's why it's little bit difficult for initial days. Just try to remember these words. What is meant by .java? Source file. Whatever the program that we write, it will be saved as .java file. That we'll call it as a source file. Once we compile this source file, then that source file will be converted to dot class file that is in bytecode language. Okay, once the bytecode language is being created, then we will convert this one to machine code or native code language that will be taken care by Java Virtual Machine, JVM, Java Virtual Machine. Okay, JVM, once this is converted, then it will be executed. So here after compilation, smooth code will be passed to JVM because there are no compilation errors, there are no syntax errors. Okay, so this is the structure that because we are converting the dot source file to bytecode language. This bytecode language will work on every operating system. That's why whatever the program that we write here will run on each and every operating system. But in C and C++, this compilation will be not there. Okay, we are not converting the bytecode. Okay, directly we are converting to machine code language, which is understandable by every machine will be having, every operating system will be having different code, machine code. So that's why it is difficult to understand. So we don't have any compilation. So we're not converting bytecode language in C and C++. That's why we are not able to run the program which we have written in C in different operating systems. So for every operating system, if we want to write a program, we need to change. If we write the same program in C, then we need to change it. For Linux, we need to change the program for Mac. Okay.
Okay.
Did you get at least 50%?
Yes.
Yeah. Okay. So that's enough for me. If you catch 50% now, you'll be able to understand once I go into deeper. Okay.
Anna, still the sound is coming, Anna. I don't know what.
Still sound.
Yeah, because the concentration is missing because of that sound. I don't know.
Yes.
Okay.
పాటలు కాదు, some phone ringing sound లాగా వస్తుంది.
టెలిఫోన్ సౌండ్ లా వస్తుంది, బయట నుంచి అనుకుంటా.
Okay.
It's like alarm.
Yeah, maybe.
Yes.
Actually, for this building, alarm system was not
Okay.
activated. Because of that, keep on buzzing whenever someone comes in. So.
Oh, okay.
That's the alarm. So because they are doing some works.
Okay.
Downstairs. I'm sorry.
It's okay.
So Nikunj, Ajay, can you able to understand Sangeeta?
Yes, sir. Hello?
Yeah, I can hear you, Sangeeta. Okay. So Nikunj, Ajay?
Yes.
Okay. So that's why Java will call it as a platform independent. Okay. This is the second one. Actually, I kept my AirPods, so it should not do any background noise, but okay. So third one is architectural neutral. This one also I told you in the morning. What is meant by architecture neutral? What is architecture neutral? So we have written a Java program. Sorry, my picture. I have written a program, Java program. Okay. That Java program will run in any operating system, right? It will run on Windows. It will run on Mac OS. It will run on Linux. Okay, whatever the Java program that we write, it will run in all the operating systems. So suppose if I change any of the configuration, if I change any configuration in the system, in my operating system, Windows operating system, that won't impact our program. Whatever the changes that we make, okay, whatever the changes that we make in the system, like if we upgrade our operating system from 10 to 11 or 8 to 9, okay, if we upgrade our operating system from 10 to 11, or if we increase our RAM, or because the processor, if we change the processor, like processor speed, we are increasing the processor speed. So these are all, we'll call it as a configuration. Okay. If we change our operating system from 10 to 11, or if we change our RAM, we are increasing the RAM from 4 GB to 8 GB or 8 GB to 16 GB, or if we are making our upgrade to processor, which is 1.8 gigahertz to 2.7 gigahertz. So this is the configuration that we are updating to our system. We are updating this. Because of updating this, our program won't impact. Still, our program will be running on this Windows. Okay. The structural architecture, whatever the architecture that is changing in the system, won't impact our Java program. Still, it will run. It won't depend on the operating system. It is not depending on the operating system. Whatever the program that we are writing is not depending on the operating system. Why? Why it is not depending on the operating system? Previously I told you. Why it is not depending on the operating system?
It is a platform.
Platform independent.
Yeah. How
Platform
it is
independent.
becoming platform independent? How it is becoming platform independent?
Means Java virtual means we are
So
changing.
dot class file, right? Which is in bytecode language,
Yes.
which will be converted to bytecode, right? Because of that, our Java program will not depend on the operating system. Okay, because we are converting source file .java file to .class file by compiling it. This is in bytecode language. So this bytecode language will be running on every operating system. That this bytecode language, whatever it has generated, that bytecode will be understandable to every operating system. So that's why it won't depend on the operating systems. So though it changes everything, that doesn't matter because this bytecode will be understandable to everything. It doesn't matter what configuration it is there, what RAM it is there, what processor it is there. Okay, have you got it? So this is architecture neutral is particular to one system. Particular to one system I'm talking. Okay, I'm talking about Windows. The same thing I can talk about Mac OS, where I can increase my RAM, where I can increase my hard disk, where I can increase my processor speed. Okay, in the same with the Linux I can increase. So this is independent to particular system. I'm talking about particular system here in the architecture neutral. Okay, just remember architecture neutral means whatever the configuration that we are changing in our machine, whatever the machine that we are using, Windows or Mac or Linux machine, that won't impact our Java program. Okay, that Java program will run though our configuration of the system got changed from one OS to other OS, from 10 to 11, or if we have upgraded RAM from 8 GB to 16 GB, or if we have upgraded processor speed from 1.8 to 2.7 gigahertz. Okay, architecture neutral. That is architecture neutral. Got it? Just remember one thing. What is meant by architecture neutral? Though we are changing the configuration in our system, that won't impact the program which we have written in Java. Still, that Java program will run in that particular system after changing the configuration. Got it?
Yes.
Yes.
Okay. So just interview purpose, this one. Okay, just interview purpose. You need to know all the features of Java. Okay. If they ask you what are the features that we have in Java, then you will say that we have 12 features. You'll be saying simple, platform independent, architecture neutral. So suddenly they may ask you what is meant by platform independent. Then you should be able to explain that platform independent in the sense we can able to run the Java program, whatever the Java program that we have written can be able to run in any operating system. Okay, if you write one Java program, that program can be run in any operating system. That is platform independent. Then they may ask you one more question. How it is working on how it is working. Then you need to say source file. Source file will be once we compile it, it will be converted to bytecode language. That bytecode language will be worked for in all operating systems. That is independent, platform independent. That bytecode language, whatever we have written is that will take care of the operating systems. That is platform independent. Bytecode language is platform independent. Okay. Got it?
Yes.
Okay. The next one is
Yes, sir.
fourth one. What is the fourth one? Portable.
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 What do you mean by portable? I already told you, right? So if you have a Vodafone SIM, you are not getting proper network in your area. You are not getting proper network in area. So you want to port. You want to port to other network, which is EE. Okay. You want to port to the different network, that is EE. So once you port this one from one network to other network, our mobile number is changing. Does our mobile number changes?
No.
No.
Right? So when we port from Vodafone to EE, when we port from Vodafone to EE, our whatever the number that we have previously in the Vodafone, the same number will be coming here. Portability. This will call it as a mobile portability. This will call it as a mobile portability. The same way for Java program also. Okay, it is portable. So whatever the Java program that we have written, it is running on Windows. That is running on Windows. Okay. We have in our office, we have all Windows systems. Then in the future, so now we want to migrate from Windows to Mac OS. We want to migrate from Windows to Mac OS. Okay. So whatever the Java program that we have written, that Java program will be running on Mac OS because this program won't impact though we change it, though we migrate from Windows to Mac OS. Okay, that is portability. Understand?
Yes.
Yes, sir.
So that is
Yes.
portable. Okay, next fifth one. What is fifth one?
Sir.
Sorry?
Robust.
Robust.
Fifth one is robust. Sorry. What is meant by robust? What is meant by robust? Definition?
Robust means strong.
Strong. Yeah. Robust means strong. Okay. Java is a very, very strong language. Okay, it's very strong language where failures will be very less. Failures will be very less. Okay, failures, whatever the program that we have written, whatever the program that we have written in Java will have very less failures, very less failures because it is first one, because it is strongly typed programming language. One is strongly typed programming language. Okay, what is mean by strongly typed? What is mean by strongly typed? What is mean by type? Okay, in Java we have different data types. Okay, that concept will come in the next coming classes. Next class. Okay, data types. We have different data types. It's strongly typed means, suppose if we have a variable x. Okay, x is equal to 10. Okay, we have declared x is equal to 10. For every variable, there will be a type. There will be a type. Suppose int. If we say integer, then we'll declare as int. Int x is equal to 10. Okay, int x is equal to 10. That means this value is an integer. Suppose if we declare int x, then whatever the value we assign to x should be an integer. Whatever the value that we assign to x should be an integer. If we assign x is equal to 10.0, 10.0 is an integer. 10.0 is an integer. No. 10.0 is not an integer. It is a float value. So automatically, the Java, what I will do once we compile the source code, then automatically Java will do left and right and throw the compilation error. Okay, it will throw compilation error. So int x is equal to int x. We declared int x. When we are assigning the value x, it should be an integer value. Okay, that's why we'll call it as for every variable, whatever we assign, for every operation, whatever we do. Suppose a plus b, this is an integer. A should be an integer value, b should be an integer value. Suppose a is equal to 10 and b is equal to some Raja, then it will give the compilation error. So because string and integer can't be added. Okay, here that Java program will throw compilation error. That's why we'll call it as strongly typed programming language. Whatever the variables, whatever the objects, whatever the thing that we are using, it has a strong type. Okay, it's a typed programming language. This will understand more when we discuss about data types. Okay, just remember that why it is robust, why it is throwing very less errors, because it is strongly typed. One of the reasons. Okay, it's strongly typed. The second one is we have exception handling. We have an exception handling. So I have written a program. Try system out println Raja. Okay, catch. Okay, let's load file from server. Load file from server. Okay, in the try block, if it comes here, it has to load file from the server. Catch. Throw an exception. Okay, then we'll write one more condition, take it from system. from local. So if whatever the file that it is looking in the server, if it is not found, instead of throwing an exception here, it will go and check it is in the local, take it from the local. If it is not present, then it will throw an exception. So like this, exception handling is very good in Java. So exception handling will be very good. So if you want to load one file from the server, if that file is not present, then it will throw an exception that that file is not present. So handling the exception is very easy in Java. It's very strong. So that's why we'll call it as a robust. These are the two points that you need to remember are robust. Okay, it is strongly typed and it has strong exception handling. Exception handling. Just remember this because we are going to study deeper in coming classes. What is meant by exception? What is meant by type? What is meant by data type? Those are all the things that we are going to study in deeper in next coming classes. Okay. The same thing. What I told you when I'm teaching manual testing, I ask you to remember one terminology, right? Just remember terminology, like what is meant by product or software, what is meant by domain, what is meant by requirement, what is meant by. So I asked you to remember these words. These definitions are given. These definitions, right? Initially, before I start manual testing, the same way you need to remember all this terminology. What I am telling now. So you'll come to know in deeper in coming days. Okay. So initially you feel like, oh, lot of things we need to remember, but later once we start writing the program, then automatically we'll be remembering all the things. This is robust. Next one, sixth one. What is sixth one?
Secure.
Secure. Yeah.
Secure.
Okay. Secure. Okay. Yeah. Sixth one is secure. How we are going to say that the Java program is very secure? How we are going to say Java program is very secure? Okay. So whatever the source file dot class file that I had told you, right? The same thing I'll tell you here. So we have a dot Java file. This is source file. Okay. Then what happens? It will be converted to dot class file. When we compile, this will be converted to dot class file. This is in bytecode. But okay, this is in bytecode because I am repeating lot of times. Okay, the same thing. Then JVM, Java Virtual Machine. What happens?
Java Virtual Machine.
Whatever the bytecode will be converted into machine code or native code language. That will be done by JVM, Java Virtual Machine. Java Virtual Machine. I'll tell you what is meant by Java Virtual Machine later. Okay. We have a .java file. This is a program that we have written that is called source file. When we compile that one, it will be created a dot class file that is in bytecode language. This bytecode language will be converted into machine code or native code language by JVM. Then it will be executed. Okay. Then it will be executed. So how it is secure? When this bytecode, we have a bytecode verifier. Bytecode verifier. Okay, so this bytecode, whatever the bytecode that we have generated, right? This it will check whether this code is in proper format. Whether it is in proper format. Whether it is generated by the system or human. it will check whether the byte code that is generated, it is a byte code. This Java will check whether this byte code is converted into proper format, whether it is sent by human or system based on the magic numbers. No need to know about magic numbers. Okay, the system will know. This bytecode verifier can able to identify this magic number that is generated here, whether it is correct magic number or any virus has been sent to the system, any virus has been sent in the program, or any format is not correct. It will check. This bytecode verifier will check whether the generated magic number is in correct format, whether it is generated by a human or a system. It will validate and check, and then only it will convert to machine code, then executed. Okay. Bytecode verifier. Bytecode verifier will check whether the bytecode which is generated is properly formatted, whether it is generated by human or system. It will check whether anyone has introduced any virus. So that thing will be checked by the bytecode verifier, and then it will be executed. If we found that the format of the code is magic code is not in proper format, then it will throw bytecode verify error. Bytecode verify error. Error will be thrown. Error will be thrown. So that means that is not going into our system and not executing it. So that's why the system will be very secure. Got it? Okay. So here validation error, validation, compilation, validation error will be thrown here. Validation error. So if this magic number, whatever the magic number generated is it, if it is not in proper format, or if it thinks that that is generated by a human by sending some virus, then immediately the compiler will throw validation error. Okay, bytecode verifier will check and throw validation error. Have you got it?
Yes. Yes, sir.
You need one more time explanation?
Yes, please.
Vishal?
Yes.
Yeah.
Please.
Yes.
Yeah, okay. Sorry. So you understood, right? .java file, how it is generated by .java file. This is a program. Whatever the program that we have written, whatever the Java program that we have written, that will be saved in .java file. That we'll call it as a source file, right?
Source file.
That we'll call it as a source file. You know about .java file, right? This is a program, student.java is a program that we have saved it as student.java. This will call it as a source file. Then when we compile it, compiler will generate one more file called .student.class. Okay. Once we compile it, it will generate student.class. That will be in bytecode. Okay, that will be in bytecode format. That means 0110 110 111. It will be in this format. Okay. This we will have a bytecode verifier. Bytecode verifier. Whatever the bytecode it has generated here, bytecode verifier will check whatever the bytecode it has generated is valid or not. Is valid or not. Bytecode verifier, what will do? Bytecode verifier will check whatever the bytecode that it has generated after compiling is valid or not. So how it is going to check? There will be a magic number. Okay, magic number format. It will check whether the code that is generated here is in the right format, magic number format. Okay, whether it will check whether it is in the right format or not. If it is in the right format, that's fine. Then it will check whether it is generated by the system, whether it is generated by proper system or human. So it will have some technical thing on the back end for bytecode verifier to check whether that is a virus or that is a proper bytecode language. It can able to check, bytecode verifier can able to check whether it is genuine or not. Okay, whether it is genuinely generated by compiler or it is someone has been introduced something onto the code and sending to the compiler. Any virus is sending to the compiler, so that can be handled by the bytecode verifier. Okay, bytecode verifier. You need to remember bytecode verifier will check whatever the bytecode that it has been generated here is in right format or not. Okay. Once it checks if everything is okay, then it will be converted into machine code. As I said, JVM will Java Virtual Machine will convert machine code or native code, then will be executed. So if it finds the bytecode verifier finds that it is someone is trying to induce some virus into the system, then this bytecode verifier will throw validation error. Okay, sorry. So this bytecode verifier, it will check whether this is whatever the bytecode that is it has generated by the compiler, is it in right format or not. If it is in right format, then it will go and execute. If it is not a right format, then it will go validation error. That means here itself the program will be stopping. Okay. Dot class file also won't generate. Have you understood?
Yeah. No, at least I got an
Yes, sir.
idea.
Yeah. Someone is trying to say something. Sunita garu?
Yeah, I understood.
Yeah, okay. Nikunj, Ajay, I think they are not responding. I don't know whether they are there. Are you there?
Yes, no, that's not like that. It's
Okay.
fine. Sir.
Ashok,
Yes, sir.
can you able to understand?
Hello. Yes, sir.
Okay. Next one, what is next one? Secure. That is secure. So that's why we'll call Java is a secure language. What is the next one?
Dynamic.
Dynamic is lost, man. Okay, object oriented. Let us discuss about object oriented. Okay. Java is a object oriented programming language. Object oriented programming language. Oops. We'll call it as a OOPS concepts. This is very important. It will take 14 hours to complete. Okay. OOPS concepts is very important. This will take us 14 to 16 hours to complete this. Okay. This will take that much time. OOPS concepts. Okay. Encapsulation, inheritance. Okay. Those are the few four of them are there. So that we will discuss in OOPS concepts. Java, we'll call it as Java is a object-oriented programming language. So that's why. So we'll call it as a object-oriented programming language. Just remember that one. So from 1.8 version, we have introduced lambda expressions. One more, functional interface. Don't worry about this, okay? Lambda expressions and functional interface. Don't worry about the words. So this we'll call it as a procedure oriented programming language. Procedure oriented. Java is a object oriented programming language until 1.7. From 1.8 it is also procedure oriented programming language, because lambda expressions and functional interface has been introduced in 1.8. This will call these two features will call it as a procedure oriented programming language. So that's why Java is became Java object oriented programming language and also procedure oriented programming language. Okay, but procedure oriented programming language was in C and C++, not there. Okay, only in Java. So just remember this one. Java is object oriented, and we have introduced two functionalities, lambda expressions and functional interface in 1.8 version. That is procedure oriented programming language. So that's why Java will be called as Java object oriented and also procedure oriented programming language. Okay, just remember this one. When we come to OOPS concept, we'll clearly discuss about this. Okay. Java is object oriented programming language and procedure oriented programming language. Okay. This is about sixth one. Seventh one, multi-threaded. What is meant by multi?
Many.
One or more.
One or more, right? So, if I had given a work to Sunita Garu, okay, if I had given work to Sunita, some work I had given, okay, some work I had given for one person, it will take 10 days, okay, to complete this work. Whatever the work that I have given for Sunita Garu will take 10 days to complete it. Okay, for one person. Just Sunita Garu only. Okay, if I add Usha into this work, what happens? How many days it will take to complete if two persons?
5.
5 to 6 working days, right? Because why I'm saying 5 to 6 working days means maybe Sunita Garu may work faster, but Usha Garu may not be that much faster. So whatever the work Sunita Garu is doing within 5 working days may not complete by Usha Garu in 5 working days, right? That's why I'm telling 5 to 6 working days. Okay. So if you take one work which takes approximately 10 working days to complete for one person, and if I add 2 persons, then that may complete it in 5 to 6 working days. What we are doing, we are increasing the persons to increase the performance of the work, right?
Work.
We are increasing the performance by adding one more resource to us, right? Increasing the performance. So multi-thread concept also will increase the performance of the Java programming because of multi-threaded. Okay, what happens? So suppose I have a code of 10,000 lines. I have a code of 10k lines, 10,000 lines of code I have written. Okay, it normally Java, what happens, right? It will run each and every line of the code at a time once. It will run sequentially. It will run sequentially, line by line, line by line. Okay, it won't jump, it won't skip this line and it won't go. It will run sequentially, one after the other line. If you have a 10,000k lines, then 10,000 lines, the 10,000 lines will be running sequentially. So to run these 10,000 lines, 10k lines of code by the Java program, it will take some 5 hours. Okay, then what I'm going to do, I will try to find out, is there any independent programs in this 10,000 lines? Independent. What is mean by independent? What is mean by independent? So I
By
have
own.
10,000 lines, right? This 5,000 lines of code, this 5,000 lines of code is not dependent on this 5,000 K. Okay. This is not depending, this 5,000 lines of code is not depending on this 5,000 lines of code. This is different and this is different. So no need to depend until to complete this 5,000 K to run this program. This is independent program, this is independent program. So what I can do, I can run both of them at a time, right? Instead of running sequentially, after completing this 5,000 K, then it will start this 5,000 K because Java program will run sequentially. So what I'm doing now, I'm dividing because this 5,000 K is not depending on this one. These both are independent programs. So what I can do, I can run this 5,000 K and this 5,000 K parallelly. So it is taking 5 hours. If you run it parallelly, it will take 2.5 hours. Right? 2.5 hours to 3 hours. So we are reducing here. The performance of the Java program has been increasing because of multi-threaded programming language. Have you understand?
Yes.
Okay. This so
Yes.
multi-threaded, whatever the multi-threaded concept we have, right? This will be discussed later. Okay. Whatever the multi-thread concept that we are discussing here, Java won't run automatically. Java can't run it automatically. Okay, so we need to introduce some files like what APIs. We'll call it as some APIs. We'll have separate APIs, application programming interface. APIs will be used to run this. So we'll be using some libraries. We are using. I'll tell you what is meant by library. What that all come under. Okay. We'll be using some libraries. Those libraries will help us to run this program in multi-threads. Okay. We have some libraries, inbuilt libraries. We are going to use those inbuilt libraries to run this program in parallelly. Okay. So we need to write a program and we need to use the libraries that are already inbuilt to run multi-threaded. So those libraries will be used while we are writing the program. If you want to run it multi-threadedly, multi-parallelly, if you want to run the program parallelly, we need to use the inbuilt libraries in our program. So Java won't run automatically. If it is a 10,000 lines of code, though it is independent, if you don't use these libraries, inbuilt libraries in our program, that won't run parallelly. So we need to add these inbuilt libraries to run this program. If you don't add these libraries in our program, then it will run sequentially. We can't use multi-thread concept. Okay, to use multi-thread concept, we need to use some libraries, inbuilt libraries that we have in Java. Okay, you understand?
Yes, sir.
Yes.
Yes.
Yes, sir.
So this is multi-threaded. Next one. Eighth one. Multi-threaded, object-oriented, secure, robust. 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 I have missed one point on robust. Okay. What I said for robust, can you tell me what are the 2 points that I have told you? What are the 2 points that I have told for you, robust?
Very strong.
Very strong. Very strong. Strongly typed.
Failures will be very less.
Yeah. Exception handling. Right?
Exceptional handling.
Yeah. Exceptional handling. These are the 2 types that I have told, right? Handling. One more point. That is garbage collector. Garbage collector. Okay. What is mean by garbage collector? Means It is a inbuilt functionality for Java program. It is a inbuilt functionality for a Java program. What garbage collector will do? Whatever the objects, unused objects, whatever the unused objects are present in the program, that will be cleared. Okay, that will be cleared. Whatever the unused objects, suppose x is equal to 10. We have declared this x is equal to 10, int x is equal to 10, and float y is equal to 20.0. We have declared this in our program, and we are not using this one, just wasting memory to allocate this, right? Just wasting memory to allocate this. While running the program, this garbage collector will check what all the objects that we are not using will be cleared, and the memory space will be emptied. Memory space will increase, right? So these are used in the program, but we are not using it. Just we have declared it. We never use it in the program. Just we declared it. This is occupying some space. Right? Memory in the program. Memory is occupying because of this declaration. So this memory will be cleared by the garbage collector. So because of this, we don't get any errors for memory allocation error. We don't get memory allocation errors. So, and that means memory is less. So sometimes we get an error saying that memory is not sufficient. Okay, that kind of errors will be gone because of garbage collector, because it is clearing all the unused objects memory. Okay, it will clear all the unused objects, memory will be cleared. So that way we are creating some more memory. By clearing this one, memory size will increase, right? So by increasing the memory size, then there is a less chance of getting insufficient memory error, right? Understood?
Yes. Like our
Yes, sir.
mobile call register.
Sorry, Sanita garu.
అంటే ఇది ఎలా ఉందంటే మన మొబైల్లో కాల్స్ వస్తాయి ఎప్పటి నుంచో ఉన్నవన్నీ
మనమే
అది
సొంతంగా డిలీట్ చేసుకోవాలి కదా, క్యాసీ అంతా మనమే సొంతంగా డిలీట్ చేసుకోవాలి ఇన్ మొబైల్.
Yeah, in
Okay.
mobile.
But here it will automatically, whatever the data that is
ఆటోమేటికల్లీ
The
unused
data, yeah,
cleared.
unused data.
So
Okay.
unused data will be cleared automatically by the garbage collector, which is an inbuilt function by the Java program.
ఓకే
Okay. Usha? అర్థమైందా ఉషా గారు?
Yes, yes, absolutely.
Okay. Next, so we have discussed about 8 right now. Now we'll go for 9th one, distributed. What is mean by distributed? What is mean by distributed? Distribution.
స్ప్రెడ్డింగ్
Spreading, yeah.
ఈక్వల్లీ
Yeah. So spreading the load into different machines. So suppose I have a web application. Suppose example, take Cineworld. Okay. So Bahubali got released. So lakhs of people are hitting onto this application. Lakhs of people are trying to book the tickets in Cineworld website. What happens? So it may crack, right? It may hang up. Application won't work. Application won't respond, and it may throw an error because the load is very high. Okay, the load is very high. Due to the load, this application may not handle that much load. At a time, 1 lakh users are hitting this application. Because of that, this application may crash. Okay. So one more example, if you take, suppose we got a results, 10th class results. Okay, when we get 10th class results, many people will face the problem saying that
Server is busy.
yeah, server is busy, right? Because lakhs of people are hitting this server at a time. Because of that, server is busy and can't able to take that much input. So that's why it is throwing an error. Server is busy. What happens? That's why we are going to create one more server. Okay, server 1, server 2. So the load will be splitted. Whatever the load we have will be splitted into. So if this server says busy, then if this server is not responding properly, automatically the traffic will be diverted to the other server. Okay, this is distributed concept that we have in Java. So load, whatever the load that is coming in will be distributed into different JVMs, Java virtual machines. Okay, JVMs. We have multiple JVMs where multiple JVMs will take care of the load that is coming up. Okay, that is coming up. If we have a load of like lakhs of 10 lakhs of load is coming, then why if one JVM is not able to handle it, we can add one more JVM so that the load will be splitted and properly that JVMs can respond properly. Okay, so distributed. So we can use multiple JVMs in Java. Okay, got it? Don't worry about JVM. Okay, just remember Java virtual machine. Okay, I'll tell you.
Okay, now I am going to ask about JVM. Okay, it's okay.
Yeah. So once I finish this one, I'll tell you about what is JVM. This is about distributed. Next one, interpreted.
Interpretive.
Interpreted.
Interpretive.
Interpreter or interpreted. Okay. 10th one. Okay. So .java file. What we'll call it as? What we'll call .java file here?
Source file.
Source file.
Source file. Right. Then what happens after compiling? What happens? What will be generated?
Bytecode line.
What?
Class dot
Bytecode.
class dot Java.
Class.
Okay. I'll show you how it is generated. Okay. Class file will be generated, which will be in bytecode.
Generated.
So you need to remember, I am telling like this is the 4th time I'm telling about this same. Once .java file, once we compile it, will be generated .class file. Okay, .java file, once we compile it, it will be generated .class file in the same folder that is in bytecode language. Okay, do remember. Okay, then JVM. Here JVM will enter. Okay, this whatever the bytecode language will be converted into machine code language or native language. Native language. Okay. Here in the JVM itself will be having interpreter. Okay. Java will be having both compiler and interpreter. Java will be having both compiler and interpreter. Okay. Interpreter means, so suppose if you take Python or JavaScript, these will call that as interpreter languages. So these don't have the compiler. Okay. This will call it as a scripting language. Scripting languages. That's why we'll call it as a scripting languages. This will call it as interpreter languages. Okay. This Python, JavaScript won't have the compiler. They don't have compiler. They have only interpreter. But Java have both compiler and interpreter. Okay, compiler and interpreter. Because of this, the speed of the Java program will be more. Okay, whatever the Java program that we are running will be executed faster than Python or JavaScript because we have both compiler and interpreter. But when compared to old languages C or C++, Java is slower. Java is slower when compared to C or C++. But when compared to interpreter languages, Java is most faster than interpreter language. Okay, have you understood?
Yes, sir.
Sunita garu, Usha.
Yes.
Okay.
Yes, sir.
Yeah. What is the next one? We have completed 10, right? We have 2 more. 10th one. High performance. Why we are calling Java is high performance language? What is mean by high performance? Why we are calling as high performance? Okay, in 1.2 version of Java, we got hotspot JVM. So in 1.2 version, we got hotspot JVM. Okay, what is meant by hotspot? I'll tell you. What is meant by hotspot? I'll tell you. We got hotspot JVM. From 1.3 version, automatically this hotspot JVM is there. From 1.3 version, automatically it is coming. So now whatever the version that we are using now, Java 11, that is already have hotspot JVM. Okay, that is already we have hotspot JVM. Okay, this will use JIT, just in time JIT, just in time compiler, JIT compiler, just in time compiler. Okay, JIT is introduced here in the hotspot JVM. JIT, just in time compiler, was introduced here in the 1.2 version. That we'll call it as a hotspot JVM. Okay, what is meant by hotspot? I'll tell you. Okay, so what is meant by hotspot means JIT compiler. Just remember, JIT compiler is introduced in 1.2 version. Okay, hotspot, we'll call it as a hotspot JVM. We are using JIT compiler, just in time compiler, just in time JIT compiler, just in time compiler will be using to compile the program. Just in time compiler will be using to compile the program. Okay, what do you mean by compiler? What is mean by compile? What happens when once we run the source code and compile it? What happens?
If any defects are there, it will throw.
Yeah. So I have a program M1. I have written a method M1. Okay. I have written a program method M1. Okay. So I'm calling this M1 method. First time. I'm calling 2 second time. I'm calling third time. I'm calling fourth time. I'm calling the same method in 4 places. Okay, I have written one method which I am calling it 4 times in different places of Java program. Okay, wherever required, I am calling this method M1. So it is 4 times I am calling our project. So this, whatever the repeated program that we have, because we are repeatedly using the same program 4 times, this repeated program will call it as a hotspot. Whatever the repeated program that we have, that we'll call it as a hotspot. Okay, the repeated program that we are using continuously for more than 3 times, then that will call it as a hotspot program. Okay, hotspot program. Okay, so now what hotspot will do? What JIT compiler will do? What JIT compiler will do? So first time we are calling this method here. We are calling this method first time. Okay, count. First it will start with 0. Okay, first it is calling. We are calling this method. What happens? It will read, compile, then execute. Then read, compile, execute. Read, compile, execute. So it will be doing, right? It is sequentially, right? Okay. What is meant by execute? It will compile and convert into machine code language, then execute. This is the sequence, right? First it compiles and generates bytecode, then JVM will convert this bytecode to machine code, then execute. Each and every line will be doing like this. So whatever the program that we have in method 1 will be doing, this is the process that the program will execute. It will compile, then it will convert the machine code language, then execute. So this will happen for all the lines of code. Okay, when we call first time. The count is 0. Okay, let the count is 0. Now we are calling the second time. Then a count becomes 1. Okay, then same thing, read, compile, convert machine code language, execute. Read, compile, convert, execute. Then it will be doing the same work. So it is converting machine code language. It is converting to machine code language, right? Every line of code is converted to machine code language, right? To execute before execution, we are converting the program into machine code language, right? Do you remember?
Yes.
So
Yes, sir.
every time we are converting machine code language, then we are executing, the program will be executed. So when we call second time, okay, the same thing will be repeated. Okay, now when we call third time, this will be second time, count will be 2. Then what JIT compiler will do? What JIT compiler will do? Once the count becomes 3, then it will store that machine code language. Whatever the machine code language for all this whole program will be stored in machine code language. Next fourth time, when it is coming to the fourth time, that it won't run this code program. Just it will take this machine code language code and it will run. So instead of doing repeatedly, so what happens? JIT compiler will understand that it is being used by the hotspot. Will understand this. Whatever the hotspot that we have, JIT compiler will understand that this program is executing more than 4 times, more than 3 times. So this machine code will be stored one place. This will be run directly instead of converting every time machine code language. Okay, I got it. No?
Yes, sir.
Yes, sir.
Yes. No. Sunita, Usha.
Yes, got it.
Okay. So this JIT compiler, what happens? It will show this machine code for the total M1 method, and when it comes to the fourth time, directly it will execute. Instead of converting each and every line into machine code, it will directly execute this one. So like this, the performance of the Java program will increase because of JIT compiler or for JVM. Okay. JIT compiler, just in just-in-time compiler. That is about high performance. That's why we'll call Java is high performance. You guys think too much this one? Is it too much?
No.
No, sir.
No.
Okay. Yeah. Next 12th one is
Dynamic.
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 dynamic. What is meant by dynamic?
Changing.
Yeah, changing. So whatever the load on demand by nature, we'll call it as a dynamic language. Java is dynamic language program. Okay, load in demand. So load in demand. What is meant by load on demand? What is meant by load on demand? What do you understand by this word, load on demand? So I have 10K markers. Okay. So if I get an order of 20K, then only I'll start increasing my, what do you call it? Increasing my, what do you call that word? My
Sales.
No, not sales. So my company is to prepare these markers. Okay. Normally my load is only 10K. Only 10K. My sale is only 10K in a year. So I'm preparing markers. My sale is 10K in a year. Suddenly, if it comes 20K, then I need to go for another 10K, right? So I need to prepare another 10K markers. So
Production.
what is happening? Based on my load, based on demand, based on demand of this marker, I'm trying to increase my stock.
Production.
Try to increase my
Produce more.
produce more. Right? So the same way here, load on demand. What do you mean by loading? I told you loading, right? I told you loading. Where I told you loading? Distributed, right?
Yes, server is busy like
Yeah.
that.
So here I'll tell you one program where class test static void static void and string args SOP load test. Okay, I'll write one more class student. Okay, I'll write static method. Okay, then I'll print SOP system.println load student. Okay, I return two methods. If JVM, do you think JVM will write two dot class files at a time? So whatever the class file, this is one class file, this is one class file, this is one Java program, this is one Java program. Okay, when we compile it, do you think that two dot class files will be generated? Test dot class and student dot class.
One after one. To
One after one?
compile it one.
Yeah, compile will be done. So suppose I am running class student. If I am running class student, only student.class file will be generated, right? Test.class file won't be generated. So whenever we required, then only that class.test file will be loaded. Else it won't load. So if I call this class, in this class, okay, test t is equal to new test. Okay, I am calling this class here. Then because I want this class here, so what happens? First it will generate dot class file, what student dot class file. Then it will print load student. Then it will come here. Test is equal to test t is equal to new test. So what happens when it comes to the line here? It will go here and it will print load test. So whenever it is required, then only it will run. Whenever there is a requirement, then only that will be running. I'm not sure whether I'm able to explain this one. Can you able to understand? No, right?
Yeah, if it is required, compile it.
I don't think so. You people got understand. I myself know. Okay, let me explain it. Okay. Load on demand. Load on demand means whenever there is a requirement, then only run that program. Okay. If there is a requirement, then only run that program. Else, don't run it. That is the concept of load on demand. So what happens? Java won't run if you have 10 classes. If you have 10 classes in a program, one program, okay, when you run it, it will run only the classes that required. It will run only the classes that required. It won't run, though, because we have 10 classes, that doesn't mean that it has to run 10 classes, right? So because of this dynamic nature, only the classes that required will be running and the remaining classes won't run. Okay.
But sir, how can we determine is it which class is necessary to run
So,
or not?
I have a test class, I have a student class, I have an employee class. Okay, I have a number student test marks. Okay, I have different classes. Okay, I have 4 classes. So if I want to know only about the employees, then just this is enough, right? This class is enough to run, right? So this class is not required to run. Only this class is enough to run. So this class will give about the employee details. Okay. This class will only use the employee details, only employee details required. So this class is enough. Though we have this different classes in the same program, but we don't require this one. So this will be skipped. Only this class will be running. So this will come to know only when we start writing the program. Okay. Suppose if I want this student data also, then what I can do? Student S is equal to new student. I'm going to create an object, student object S. So I'm calling this student here. So if I want marks, then I'll call marks M is equal to new marks. Okay. So if we require, we're going to call it there. If it doesn't require, just leave it. So that classes also won't run. So this is object oriented, right? Everything is object. So what is meant by class? What is meant by object? why we need to use objects and all that I'll explain you. Okay, just for remember, whatever the classes that require those only will be running in the Java program. That's why we'll call it as a dynamic. Though we have multiple classes, but all classes will not run. Though we run the program, it will run only the classes that required for that particular class. Got it? No?
Yes.
Yes, sir.
Okay. This is
That will be more clear when we start writing program.
yeah. So you'll understand. So you'll understand. So first of all, you need to know what is meant by class. Okay. What is meant by class? Anyone? What is meant by class and what is meant by object? Class is a blueprint. Blueprint. Okay. What is meant by blueprint? Anyone know?
Number of persons.
Sorry?
Putting all together.
Yeah.
Number of
Blueprints
persons.
are ideas and
Yeah, idea or plan, right? Blueprint or plan. We'll call it as a plan, right? So blueprint or plan, which will help us to create, number of objects. Create number of objects. Is called as class. Class is a blueprint or plan which will help us to create number of objects. That we'll call it as a class. For example, you want to construct a house. What you will get first?
Blueprint of the house, like
Planning.
construct.
We need a planning
Planning.
information, right?
Planning.
So now I have a land of 10 acres. Okay. I need to construct houses in 10 acres, some 100 houses. Okay. I'm building 100 houses. Okay. I'll bring the plan for this whole 10 acres, 100 houses. Each house will be same plan. Each house will be having the same plan. Okay. So have you seen, right? If we go and see any apartments or any gated communities, how the houses will look similar, right? Every house will be similar, right?
Yes.
Right.
yes, sir.
So he will prepare a plan. So the house should look like this. In 10 acres, if he wants to build 100 houses, all the 100 houses will be having the same plan. Okay. So here, plan is a blueprint. Plan, we will call it as class, and individual houses will call it as an object. Individual houses is called an object. If you take an individual house, it is an object. So now, did you get what is meant by class? What is meant by object? So if you have a plan, we can create number of objects, right? We can create multiple objects, right?
Yes.
So Raja can eat, Raja can walk, Raja can run. Raja is a class.
Class.
Okay. Whatever the activities that I am doing are objects.
Objects.
Object, sir.
Okay.
Object.
Have understood? Whatever Raja is, Raja means is a man or female, male or female. If I say male or female, it is a class. If I consider male or female, we'll consider as a class. And Raja, Sunita, Usha, Ajay, Ashok, Madhu, all these will call it, these are objects of a man or male or female.
Female.
Got it?
Yes, sir.
So if you take male or female, okay, this will call it as a class. Okay. Physical members will call it as a objects. Physical.
Objects.
This is just assumption. Just an assumption. Class is an assumption. Plan is an assumption, right? Whatever the plan that we are beginning to build a house is a plan. That is an assumption, right? The house will be looking like this. That is a plan. That is an assumption, right?
Yes.
Once
sir.
we build the
Plan
house,
will execute and we will get a product that is
that is an object.
object. Yes.
Yeah.
Yes, sir.
Got it? What is meant by class? What is meant by object?
Yes.
Got it, sir.
Yeah. So that we'll call it as a class and object. These things will be using everywhere in Java. Without class and object, no program will be writing. We are not writing a single program without object or class. Okay. We'll be writing all the programs using object and class. Okay. So that's important concept that we need to know. Okay. Any doubts? Any doubts for today?
No.
Today we will learn and after
No,
that
sir.
let you know the doubts.
Sorry. After today, we'll be having more doubts. Nikunj? Okay. So
Yes, I just
tomorrow
spoke.
we are going to discuss about language fundamentals. Okay. We are going to discuss language fundamentals. This will take 2 classes. Okay. We are going to discuss about language fundamentals tomorrow. So Java features, I'll send the notes. Please go through once and try to remember all 12 features. So if someone asks you about what are the Java features, then you should be able to tell all the 12. And if they ask something in middle, like what is platform independent, why we are calling Java as a platform independent, why we are calling Java as a robust, why we are calling Java as a architectural neutral. So if someone asks you, you should be able to tell. So that is important for only interview purpose. I told Java features only for interview purpose. Okay. Well, once we enter into the job, we are not at all bothered about what is Java feature, what is the language fundamental. We don't even bother. Okay. Just we need to know the concept. We need to know the definitions. Just we need to know the definitions. No need to have. We need to have only concept. No need to by heart anything here. Okay. No need to by hand. Just concept. Just explain whatever you think that is. No need to by heart and no need to use the same words here. Okay. So tomorrow morning we'll connect at 8:15. Okay, 8:15 to 9:30. We'll start discussing about language fundamentals. Okay, that is for today's class. So feel free to come back to me if you have any doubts. Okay, from tomorrow we'll be starting using our laptop. We'll be writing small programs. Okay, two people also need to write and execute and check whether the program is working or not. So from tomorrow, definitely we require a laptop. Everyone should be installed Java. Please try to install Notepad++. Okay. That will give us exactly where the error is showing. We can run it in Notepad also. We can run the program from Notepad also, but Notepad++ will give exactly what error is showing. The colors also it will show in Notepad++, because we'll be having the source code option. While we were saving, we can select source code, Java source code. We'll get an option to select Java. Here in Notepad, we need to select only all files. When we are saving, we can select .text file, right, or all files. Only these two options will get in Notepad. But when it comes to Notepad++, we'll get .text file, we'll get .java source code file. We'll be having .java source code file. So while we are saving, we'll select this option and save it. Okay. So that will be easier to understand if you have a Notepad++. So try to install Notepad++. It will take just 1 minute to install, download. It's a small file. Okay. So be ready by tomorrow morning. So from beginning, from the first 10 minutes, we'll start writing the programs. Okay.
Okay, sir.
Thanks for joining. Tomorrow 8:15. Between Indian timing, it will be 12:45 p.m. Okay. Here 8:15 a.m. Okay. Thank you. I'll share the link for this by tomorrow morning.
Thank you.
Okay. Thank you. Bye.
Thank you.
Thank you.
Have a nice weekend. Nice evening.
Nice day.
Yeah. Thank you. Bye.
Bye.